Hello everyone, in this video I am going to cover what is probability distribution function and how can we define mathematically for discrete and continuous random variables. In this video I am also going to cover little bit about what is cumulative distribution function, but more details will be shared in the coming video. So let me start with random variable. A random variable is a function that assigns a real number to each outcome of the sample space. Sample space is a set of all the possible outcomes of a random variable. Consider rolling a dice. If we roll a dice, then possible outcomes will be either 1, 2, 3, 4, 5, 6. So the set of all these value is sample space. Similarly, when we toss a coin, the sample space will be the set of head and tail. Okay. So mathematically we can define random variable as a function from sample space to a real number. How? For example, while tossing a coin, we are saying that what is the probability of occurrence of head? It is half, right? So what we are doing here is that we are mapping the head, which is the one of the element of a sample space, to some real number, which is half here. Similarly, we can quantify the outcomes of any random variables by saying that random variable is a function from sample space to a set of real number. Now talk about the type of random variable. It is discrete random variable and continuous random variables. Discrete random variables are those random variables which can take the discrete value, like score run by Virat Kohli or rolling a dice, tossing a coin. All these are an example of discrete random variable. Talking about continuous random variable, those variable which can take continuous value, right? Like those random variable which can take continuous value. For an example, let's take an example of temperature measuring at a point. So if I am measuring a temperature at a point, then temperature can vary from, let's say, 10 degrees centigrade to 15 degrees centigrade. So it is continuous, right? It can take any value between 10 to 15 degree. So it is in continuous. Now let's define probability distribution function. Probability distribution functions says how probability are assigned to the value of the random variable. It is similar to what probability is, but in a more general terms. Let's start with discrete random variable. For discrete random variable, probability distribution function is probability mass function, and which can be like in notation we can generally is probability of x equals to x. Sometimes someone's also noted it as something like this or something like this. So it is just a general terms, you can notate it anyway. Let's take an example of rolling a dice. When we roll a dice, the outcomes will be either 1, 2, 3, 4, 5, 6, right? So it is like whole sample space 1, 2, 3, 4, 5, 6, right? And what is the probability associated with each random variable, like each outcomes of the random variable? It is 1 by 6 for each outcomes, right? Hence we can say that random variable probability distribution function is the function from x, like the sample space of x to some real number, right? And this is discrete, so I am defining it in a discrete way. Now move to continuous random variable. Continuous random variable, the distribution function is probability density function. Don't confuse with probability density function is PDF. No. PDF, probability density distribution function, is a generalized terms for discrete as well as continuous random variable, and PDF is for continuous random variable, which full form is probability density function, and its notation is usually f of x equals to x, or sometimes you can also define this as similar to like this or sometimes this. Okay, now let's take an example of normal distribution. Normal distribution is bell shaped like curves where the x can take value from minus infinity to infinity, and it has some mean value. Mean value, like it's a central value kind of things, and it can be mathematically noted by f of x equals to 1 by under root 2 pi sigma e raised to minus half x minus mu by sigma ka whole square. This is called normal distributions. Okay, it is similar to saying like that what is the probability of a temperature at a place varying from 5 to 10. It is similar, like it might be probability distribution functions might be normal, or it can be any distribution, right? I am just taking examples. If in case if mu is 0 and sigma is 1, then we call it a standard normal distribution. Why? Because its distribution will be something like this with mean 0 and standard deviations varying from like 1 and 1, like 1 standard deviation and so on. Now let me give you a glance of what cumulative distribution function is. Cumulative distribution function says what is the probability. Let's suppose that f of x is a random variable, f of x equals to x. It is equals to probability of x less than equals to xn. So what is the probability that x is less than, let's suppose, 10? What is the probability that temperature is less than 10? So this can be quantified with the help of cumulative distribution function. So we have to what we have to add all. I think I have made a mistake here. It will not be xi. It will be summation of probability varying from 1 to xn, right? And for continuous random variables, similarly, I think I made a mess here. It is integration of f of x from minus infinity to x. It might be confusing to you, but let me show you pictorially. So let's suppose that this is the normal distribution, and we know the, like, this is the PDF of normal distribution. Now, if the question says that what is the probability that, let's suppose this is 10, what is the probability that this x is less than, let's suppose that 5. So 5 will be something like here, right? So this will be whole, like you can say that this area, right? This area. So whole this area is what, like this is the answer of this, right? This probability x less than 5, and this is noted by f of x equals to 5. Okay. Similarly, we can also define for discrete random variables. Before ending this video, let me ask you a question. I think I don't have a questions for now, so let's end this video. Thank you.